So today what we're going to be doing is graphing functions, and this is the third part of a function graphing sequence. First, we're going to identify the slope of the function, and then we're going to see if we haven't noticed if the line has been moved, and we're going to graph that accordingly. Now, let's take a quick look at this function. I know this is a linear function because my x is to the power of 1, which means that the slope is going to be the number in front of the x. So I know that this right here is my slope. So I have a slope of 1/2. Or also, I know that I have a rise of 1 and a run of 2. So I'm going to be going up 1 over 2, up 1 over 2, up 1 over 2. And I'm going to see if I can't figure out if the graph has been translated, which means moved, and we're going to graph that accordingly. So for the first one, what we're going to do is we're quite literally going to make a table. And so let's bust out a nice little graph here. So for function 1, we're trying to graph f of x is equal to half of whatever we plug in. So I'm not necessarily sure where this graph is going to end up, so I'm just going to go ahead and give it a couple x values, because remember, a function says we need to plug in x's into our equation in order to get an answer. So I'm going to make an x, y, or if you really wanted to call this, you could say this is an x slash f of x table. Remember, y and f of x are pretty much the same thing. And let's graph a few points. Let's say -3, -2, -1, 0, 1, 2, and 3. Let's graph several different points here to see where we end up. Whoop, big old table here. And remember, we're taking half of whatever we plug in. So in this case, I'm taking half of -3. Now, our first thought should be, hey, with this, I know that -3, first off, I can't just multiply fractions with whole numbers willy-nilly. I got to put that -3 over a 1. And then this allows me to say top times top. So 1 times -3 is going to give me a -3. Then bottom times bottom. So 2 times 1 is going to give me a 2. And there we go. And I'm going to do that all the way down the list. But for this one, when I take half of a number, and the number I plug in is -2, I notice something slightly different, not too terribly different, happens. First off, I have to put the 2 over a 1 in order to say, okay, 1 times -2 is -2. 2 times 1 is 2. I notice this can actually reduce. -2 divided by 2 is -1. So albeit this was finished, this I could take one step further. And we'll notice that some of these will reduce and some of these won't. So let's go ahead and take half of each value. And why don't you go ahead and pause the video and give it a shot and see how well you do at taking half. See which ones reduce and which ones don't. If not, we're about to walk through them here in just a moment. Okay, so we said, hey, we're taking half of each one of these numbers. First off, we know that each one of these whole numbers needs to be put over the number 1 because we're multiplying each one of these by a fraction. That way we can multiply the top 2 of each number times the bottom 2. So quite literally what we're looking at is we're looking at what is 1 times -1? Well, that's -1. And then separately we're saying what is 2 times 1? 2. And then we're asking ourselves, does -1 divide by 2? No. So we stop. Here we say, what is 1 times 0? 0. What is 2 times 1? 2. We ask ourselves, does 0 divide by 2? And the answer is yes. 0. 1 times 1, 2 times 1. Does it reduce? No. 1 times 2, 2 times 1. Does it reduce? Yes, it does. 2 does divide by 2. 2 divided by 2 is 1. Top times top, bottom times bottom. And that does not reduce. So it looks like every other one is reducing. So let's take a look at what this does to our graph. And so we have this table of values. One of the things that you might want to do that I find particularly handy is I will rewrite this table without all the work on here. And that makes my life a little easier to track what's going on. So I'll make an f of x, or remember, we could just call this y, table. And I'll plug in all my values, -3, -2, -1, 0, 1, 2, and 3. And I have a -3 halves, -1, -1/2, 0, 1/2, 1, and 3 halves. And literally all I did was I copied all my values of my x's and all the answers that I got after I plugged them in. And that allows me to kind of focus more on what the graph is doing and less on the work I did to get this table created. Okay. So now we're going to look at, we know that -x means left. We know that positive x means right. I know that -y means down. I know that positive y means up. So I'm going to look at my extreme left and right values and see which one is farther away from 0. I got -3 and +3. So my left and right are equally balanced. So what that means is I'm going to take my graph and I'm going to balance the left side and the right side. So I'm going to put my axis right here in the center. And I'm going to do the same with my up and down. I'm going to say, let's look at the farthest numbers, -3 halves and +3 halves. Well, they're exactly the same distance away from 0, so I'm going to make my graph directly in the center. That's going to give me just the same amount of room up as I did down. So I have an x and a y. Let's see, for my x values, 1, 2, 3, I'm good on that front. 1, 2, 3, I'm good on that front. I can count by ones and not have any issues. Let's see, I need to get to -3 halves, which is -1.5, so that works. And I need to, yep, that works. In fact, what I could do is I noticed that because my final number and several numbers in my table are halves, I could check to see, why don't I try counting by halves? So 1, 2, 3 halves, that works. 1, 2, 3 halves. In fact, that works a little better. It gives me a little bit more room to work with here. Okay, and so let's do that. I'm going to go left by 3, counting by ones, and then down by 3 halves, counting by halves. So 1, 2, 3, down 1/2, 2/2, 3 halves. I'm going to go left 2, counting by ones, down 1, but I got to count by halves, so that's 2 halves. Boop, boop. Left 1, down 1/2, 0, 0, 1/2, right 2, up 1, which is 2 halves, and then right 3, and up 3 halves. Boom, and so we have that. Now we're going to connect our points with a straight line. And I'm always going to draw my line a little outside of the graph. And when I do that, I'm going to put arrows on the ends. What that tells the person who's reading this graph is that what we've graphed actually can keep going. It goes beyond the graph by the arrow and by the slight extension. That tells them that if we wanted to graph like a 4, a 5, or something way out here, I could, but we didn't. We got a good image of what the graph looks like right here. We're going to label this. This is an f of x. So near one of these arrows, I'm going to say this is f of x. You could put it up here if you wanted to as well. And I have 2 points to label, where it crosses this axis and where it crosses this axis. In this case, both points are the same right there, and I go hunt down and say, well, where is my 0? And it's going to be right there, 0, 0. Okay, so when I look at this graph hasn't been moved. It's right in the center, it's at 0, 0. What we're going to notice in the next one, when we take a peek at number 3, this graph may or may not have been moved. And take a look at the two equations and see if you can't tell me what's different about the setup of the two equations. Well, you might notice that we have something added to this equation. This thing. It's still my half x, but I'm adding a 3/2. And that causes us to sit there and wonder, okay, if I still have this thing right here, I still have a slope of 1/2, which means I still have a rise of 1 and a run of 2. What does that have to do with it? Okay, well, there's really only one way to find out. So what we're going to do is, again, we got to come up with some points to graph, so why not go ahead and do what we just did right here and make ourselves a nice table. So let's go ahead and get that set up. So for number 3, f of x is 1/2 x plus 3/2. So I have an x. When I plug that in, I'll get an answer of f of x, which is the same thing as saying y. You know what, let's plug in the same points. This will give us a nice point of, or points of, LOL, math jokes, points of comparison. Boom. So we're taking half of the number, and then we're adding 3/2. In this case, I'm taking half of the number -3, which we remember from previously, anytime we take half of a whole number, we have to put that whole number over 1. And what that allows us to do is that allows us to say, hey, top number times top number. So 1 times -3 is -3. Bottom times bottom, 2 times 1 is 2. Then I'm going to just translate this plus 3/2 over. Now, a common thing that students like to do when they add two fractions together is they'll want to add the tops and the bottoms, and they'll say, hey, doesn't this, well, -3 plus 3 is 0 over 4. And albeit you'll get the final answer on this one, that's not how we do it. We don't actually add the denominators when we add fractions. We remember the fact that if they both have a common denominator, what we can do is we can say, okay, they have a common denominator. The tops is what I'm worried about, -3 plus, that's a 3 if you believe it. So -3 plus 3. Now that is a 0 over 2, which reduces down to a 0, albeit it's not a 0 over 4. So if it was anything other than 3's, we would have been in trouble. So let's try one more of those, make sure we got that concept down. So 1/2 of, we have -3. Again, my 3's and my 2's seem to be a little wonky, but that's okay. That's actually a 2. I got to put the 2 over a 1, which means I say top times top, bottom times bottom, plus a 3/2. And because these have a common denominator, I put them over a common denominator. So -2 plus 3. -2 plus 3 is 1. And that is a 1/2. There we go. So if we try that one more time, I know I'm going to have to take this -1 and put it over a number, so that way I can successfully multiply the top 2, which is -1, over the bottom 2. There we go. And that gives us a common denominator of -1 plus 3, which is going to give me a 2/2, and we say, yes, 2 can divide by 2 to give me a 1. So why don't you go ahead and see if you can't finish us this table while we're working this out. tops, bottoms. Common denominator set up. So 0 plus 3 is 3. Good. Tops, bottoms. Common denominator is already set up. So 1 plus 3 is 4, which does divide by 2. Tops, bottoms. Now, it might be tempting. A lot of you might look at this and say, well, doesn't that reduce? And yes, it does, but we're still going to be adding these two fractions together. So even though this would reduce, we're going to wait until the end to actually do that reduction. Oh, so that was actually going to be a 2 plus 3, which we got ahead of ourselves there, which is a 5 halves. Reduces down to a 3. Boom. And there we go. And so we're going to copy down our table onto this right here so that we can kind of ignore all this work that we did. Let's say x, f of x, which is the same thing as saying a y. Let's see, we had 0, 1 half, 1, 3 halves, 2, 5 halves, 3. Okay. Well, if I'm setting this up like we did previously, we know that my negatives are going to be left, and my positives are going to be right, and my positive y's are all up. So you notice how prior I had some portion of the graph that was going down and some portion of the graph that was going up. I don't have that anymore. Everything has gone up. Which means, what do you think this plus 3 halves is going to mean? That must mean that the graph has moved up. How much? Well, let's see if we can't figure that out. Well, just like what we did before, we know the left and the right, we're going to check to see the balance. -3 and +3 are the same distance away from 0. So I'm going to go ahead and make the left and the right side of my graph balanced by drawing my 0 line, or my y-axis, right in the middle. However, because the graph is all positive values, there's no reason to include all this negative space down here. I'm going to put my axis right at the bottom. Perfect. And in fact, because this is the same slope, I'm going to keep the same scales. I'm going to keep the 1s and the halves going. Okay. That allows me to go left 3 and at 0. Left 2, up a half, up 1, which is 2 halves, up 3 halves, right 1, 4 halves, 2, 5 halves, and 3, which is 6 halves. We are going to connect this with a line. A little beyond the graph, so we can draw our arrows to say, hey, there's more to this. We just didn't draw it. We got to label it, and instead of labeling it down here, I'm going to label it up here. So f of x. My 2 points are that intercept and that intercept, where it crosses that line and where it crosses this line. So where it crosses this line, I have a point where my y was 0. Boop, it's right there. So -3, 0. And then I have another point right here where my x was 0, which is right there, 0, 3 halves. And so we're going to notice that this graph means one of two things. Judging by the fact that it is some sort of a translation, because it's been translated, of our number 1 graph, we know that it looks like all of our things have been moved up. And so we could say, hey, either the graph has moved up, or we could say it's moved to the left. But really the easier of the two is notice how far it's moved up. I went from 0, 0 to 0, 3 halves. What was that term we had over there? 3 halves. How far up did we move? 3 halves. So not only did it move up by exactly that. Awesome. So that's a really interesting point that we've got. I wonder if we can't use that to graph a little faster. Well, why don't we take a little bit of practice and try predicting on numbers 5 and number 7 if the graph is going to be moved up or down and what's going on. So go ahead, pause the video, give it a shot, and see what you can do. Okay, so assuming you've given a shot on this, we notice that right here our slope is a negative. So our slope is -1/5, which means we have a rise of -1 and a run of 5. So I'm going down 1 over 5. On this one, our slope is, we have a slope of -3/4, which means we have a rise of -3. We're going down by 3 and a run of 4. And then from what we did previously, we bet the fact that what we've got going on right there is we're betting the fact that we've moved up by 1/5, because that's +1/5. This one's a +1/4, so we're betting that we've moved up again, but this time not by 1/5, but by 1/4. And so let's see if our graph doesn't intercept one of those lines at a 1/5 and a 1/4. And if so, that'd be a really cool way to graph these things. So let's go ahead and bust out our trial paper, which is just fancy word for saying we gotta graph all this. And for number 5, I'm gonna plug in a set of numbers into this. Now I'm gonna speed up the video because this is gonna be a rather mundane process, but just go ahead if you want to. I'll actually have this playing through, but it'll be on a much faster speed. Boom. Okay, so there's our first one. And now I'm gonna go ahead and work out the second one so that we can have both values and we can pop these both on there. So here we go. Okay. So some of these, what I notice is the fact that when I have this 9 plus 1 over 4, 10 divided by 4, 10 doesn't divide evenly by 4, but what I do notice is that both 10 and 4 can be divided by 2. So what ends up happening is we have a 5 over 2. Now this is going to be our final reduced answer, but the 10/4 might be what's going to be easiest to graph. So be aware of the fact that we're going to have two different values that we're going to be looking at. One that is our answer and one that we might be using to graph, because they're all going to be over a 4. But let's move on. Perfect. So we had a couple of those cases where I couldn't fully reduce it, but I noticed that 2 and 4 both divide by 2, which means 2 is exactly half of 4. Same thing with the 10 over 4. 10 doesn't divide evenly into 4, but they both divide by 2, so I'm dividing them both, and that's exactly the same as 5 halves. Now, I'm probably going to be looking at these values when I'm graphing because, again, it's a consistent change over 4 as opposed to what's going to be going on over here, which may or may not be consistent. But regardless, let's take both of these values and transfer them over into our tables, starting with number 5. Okay, so now let's go ahead and take a look at our distribution of our graphs. I know that I have 3 numbers going to the left, and I have 3 numbers going to the right, and I have, looks like, 4 numbers going up and 2 numbers going down. Likewise here, I still have 3 going to the left and 3 going to the right. We notice this is always balanced because we picked these numbers. So we tend to pick numbers around 0. So it's artificially locked in that way. But these I have, it looks like, 4 going up and 3 going down. And so here my left and right are balanced. -3 and +3 are the same distance away. So my axis goes directly in the center. The same is going to happen to number 7, because number 7 also has a left and right maximum of -3 and +3. So left and right is balanced, so my axis goes directly in the center. Perfect. Now, what gets a little varied here is that I have, let's see, 4/5 going up and 2/5 going down, which means I need more room going up than I do going down. So what I'm going to do is I'm going to take my graph and I'm going to scooch it down just a little bit. I'm not going to move it down too much. Let's say by about 2 blocks. Do you need to do this? No. Does it make graphing a little easier? Because it kind of gives you more space where you need it. I need a little more space up, gave myself more. Little less space going down, so I gave myself a little less. I could put it directly in the center, but I'd have a lot of wasted space down here. So same with this. I've got a little more up, but let's take a look at the values of those things. So 5/2, well, let's see, my -2. So I have 5/2, and if I compare this to halves, that's -4/2. So they're almost the same distance away. I have a tad bit more going up. So I could put it directly in the center. What I'm going to do is I'm going to move it just 1 down. You could probably just leave it in the center, but I'm going to take a risk and move it just a little bit down. We know that to move left and right, it's easiest to count by 1s with these. So both my x's are going to be counted by 1s. And here's a trick. On number 5, I'm counting by 5ths. So I could try and count a 5th of the block up and graph those things, but why not make each block worth a 5th? That way I can just look at the top number and say, well, I can count up by 4/5, so I count up by 4 blocks. 2/5 would be 2 blocks, 1/5 would be 1 block. -2/5 would be down 2 blocks. So I'm going to do the same thing here. Now I have halves, fourths, and whole numbers, so that's going to present an issue. So let's see, I could do it by 4ths, but what that would do is I'd be only able to go up to, let's see, so that one, even though it's not the most extreme, 1, 2, 3, 4, 5, 6, I wouldn't be able to hit it with 4ths. So what I could do is I could just settle with halves, and no 4th is going to be treated as a half block. So let's see if that helps us graph this stuff. So I'm going to go left 3, 1, 2, 3, up 4/5, so up 4 blocks, 1, 2, 3, 4 blocks. Left 2, up 3 blocks for 3/5. Left 1, up 2 blocks for 2/5. 1 block for 1/5. Nothing. Down 1 block for 1/5, and down 2 blocks for 2/5. And what that gives me is that gives me a really pretty line that seems to have demonstrated exactly what we thought was going to happen. Let's see, I'm going to put my f of x right here, so I've got it labeled. Now I have two numbers I need to label, that one and that one. This one luckily is on my table because I know that my x value is going to be 0. So it's 0, 1/5. This one, my y value is going to be 0. Luckily, that's also on my table. So 1, 0. And lo and behold, what do we notice? Our line has moved up by 1/5. So perfect. If you take a look at the next one, same thing. Now, if I'm counting by halves, first, some of these are going to be easy. So -3, 1, 2, 3. And 5 halves is 1, 2, 3, 4, 5 halves. Let's see. This one's going to be easy. So that's +1 and down 1/2. The rest of them will have to do a little bit of creative thinking. So for -1, +1, well, 1 is just 2 halves. So -1 up 2 halves. 2 is going to be 4 halves. So I'm going to go right 1, 2, 3 and go down 1, 2, 3, 4 halves. It looks like I'm doing pretty good because they're in a straight line. Now these fourths. So I know a fourth is going to be half of a half. So left 2, 1, 2, 3, 4, 5, 6, 7 fourths. So 7 halves of a half. Here is just half of a half. And that one, I'm going to go down 1, 2, 3, 4, 5 halves of a half. And we notice that by using that logic right there, we can go ahead and make a straight line. And now, unfortunately with this is our first time where I notice that I have a point right here that I don't know what it is because there's no point right there and I don't have a y value that's equal to 0. So we're going to figure out how to find that in a future video. But for this one, I've got this, and that's 0, 1/4. And lo and behold, what did we predict the line moved up by? 1/4. So there we go.